part 3. We're going to condense each expression into a single logarithm. So this number out here can become the exponent for this. So this becomes log base 4 of 2c cubed minus, and this 1/2 can come up here. So this is log base 4 of 64 to the 1/2 power. So that's log base 4. This 2c cubed, 2 cubed is 8. So 8c cubed minus log base 4, 64 to the 1/2 power is 8. So the subtracting becomes a single log base 4 of 8c cubed divided by 8. The 8's cancel out, and then we are finally left with log base 4 of c cubed. All right, number 64. So we will start by making that 3 an exponent, and then this addition, these we're going to get to multiply. These parentheses are important because I still have this 1/4, and then all this happens before that happens. I don't get to put the 1/4 just on the 256 or anything. So I get 1/4 times the natural log of 256 p cubed minus the natural log of q squared. Okay, so this 1/4 can become an exponent here, and this is subtraction, so we can change it to division. So I'll have a single log. The 1/4 only goes to this, so it's going to be 256 p cubed all to the 1/4 power over q squared. All right, so 256 to the 1/4 power, I can take the square root and square it again. Square root of 256 is 16. Square root of 16 is 4. So get the natural log, 4 in the numerator, and then this is going to be p to the 3/4 power, or that 1/4 is a 4th root. So it's the 4th root of p cubed over q squared. All right, so then I want to expand. When I expand 65, then this is going to become minus the log because this is in the denominator. I can change this 1/5, or this 5th root can become 1/5 on each one of those things. I'm going to leave all of this stuff together to begin with. So I'm going to expand it like this. I'm going to take log base 6 of n plus, now this is the 5th root, so this is all of this here to the 1/5 power, so I'll just go ahead and bring the power out front, times log base 6 of, and then this still is just 2m squared, but I can add that, so if I separate that, I'm putting parentheses here, so log base 6 of 2 plus, and that m squared is going to be 2 log base 6 of m, and then that minus the denominator, which is log base 6 of 5. Okay, then I need to distribute that 1/5, so that'll give me log base 6 of n plus 1/5 log base 6 of 2 plus 2/5, because I'm distributing this 1/5 in there, 2/5 log base 6 of m minus log base 6 of 5. There are, of course, different ways for you to get to that point. If you'd have distributed the 1/5 to begin with or whatever, you may not have had parentheses within there, but that's what you get in the end there. Okay, 66. We are going to, I'm going to start by going ahead and distributing that. I'm going to do the power to the power. So I have this 3rd power, this 3, basically will get distributed to all of it. So I get the natural log of 4 to the 3rd, a to the 6th, b to the 3/2. So we want to separate all that out. The natural 4 cubed is 64, so this is going to be the natural log of 64 plus 6 times the natural log of a plus 3/2 natural log of b. so now we're going to solve them using some of those same skills. So it says solve each equation rounding to the nearest 10,000th, though, but we're not doing that. I think a little better than that at this point. So I need to condense first. You have to have a single log on each side. I cannot stress that enough. Log equals log. Even if you know what's about to happen, it doesn't matter. So I have addition here, so I can condense this by multiplying. So this will give me log base 7 of 6 times x plus 1 equals, then this 2 becomes an exponent, log base 7 of 4x plus 1 squared. Okay, so now I have single log on each side, same bases, so now I can use the one-to-one property, which tells me that this part equals this part. So as I take it out of there, I'm going to distribute and simplify some. So this gives me 6x plus 6 equals, when I square this is going to give me 16x squared plus 8x plus 1. That is a quadratic, so I set it equal to 0. Get 0 equals 16x squared plus 2x minus 5. I factor that, get 0 equals, it's going to give me 8x plus 5 times 2x minus 1. You may need to do some grouping or something there. I'm just not going to take the time to go through that whole process. So my x values then are going to give me a negative 5/8 and a positive 1/2. Then I need to check them because these are logs. I got to see which one's actually going to work within my original function. So the original one. This negative 5/8 doesn't do anything there. Negative 5/8 would be giving me a positive number right there. 4 times a negative 5/8 is definitely going to give me something bigger than 1 as far as way smaller, but negative, so 4 times negative 5/8 is going to be a negative number that when I add 1 to it is still going to be a negative number. That's a bad thing. So that does not work. This 1/2 will work fine in all of them. So my answer in the end is just 1/2. Okay. So on number 68, I need to condense this. So this is subtraction, which gives me a single log. And I divide. It's equal to 1. Now I cannot use the one-to-one property because I don't have a single log on each side, so I need to reuse my exponentials. The base here is e, so it would be e to the first power equals this. So e to the first equals w plus 6 over w plus 4. So then I have to solve for w. I'm going to multiply both sides by w plus 4. So I get e times w plus 4 equals w plus 6. So in order to get the w's together, I'm going to have to distribute my e and then get all my like terms together. So this is going to be e times w plus 4 times w equals, oh, no, that is not 4 times w, dang it. E times w plus 4 times e, because e is what I'm distributing. Once my board decides to cooperate, I will fix it. Oh, it's tired. Okay, so this should be plus 4e. That's what I meant to do. Equals w plus 6. So I need to get all my w's on the left. So this will be e times w minus w equals 6 minus 4e. Factor out my w. It's going to give me e minus 1 equals 6 minus 4e. Then I can divide. So I get w equals 6 minus 4e divided by e minus 1. And if you get a super weird number like that and it's hard for you to check it, like I don't know if that works or not, if it's positive or negative, that sort of thing. Actually, you should know if it's positive or negative because this 4 times e, remember e is a little bit less than 3, so you can kind of estimate. So this is a little bit less than 12. Minus 6 is going to be a little bit, you know, not really negative 6, negative 5 something over 2 point something. And so it is going to be a negative number. It's about a negative 2.8-ish. And so it will work in here. But if it's crazy like that, I really don't expect you to feel comfortable enough to say, hey, I know exactly what that is. And it's going to work or not. As long as you can solve it, you're good. All right, then 69. I need to get all the same bases. You could leave it as a fractional base. I think most of you feel a little bit more comfortable when it's not a fraction. So yes, 9 squared is 81, but I can't use a 9 here. I'm going to have to use a 3. So we'll make 3 our base. This would be to the negative 3 power. So negative 3 times 3k minus 2 equals, then my base is 3 here. So to get to 81, 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's 3 to the negative 4th times 3. And then, so 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So that's going to be 3 to the 5th power times 4 minus k. I cannot take them out of the exponents right now. And the great majority of you that made this crazy wrong mess of this stuff did that here and then went forth and did everything completely wrong. First of all, this is not the one-to-one property yet, so it's not legal anyway. And some of you did take it out of the exponent at this point and then still did everything correctly moving forward, but basically you didn't apply the rule correctly. I have to take it at least one more step in the exponents here. So I can go ahead and rewrite the left-hand side and I'll distribute as I do that. So I have 3 to the negative 9k plus 6 power equals, and then when I multiply exponentials with the same base, I add the exponents. So the base 3 would be negative 4 plus, and I'll distribute here, this is 20 minus 5k. So now I have single base on either side. Now I can apply the one-to-one property, and I can take this information out of the exponents. I can simplify as I do that. So the left is negative 9k plus 6 equals, then over here I'll clean that up a little bit, I get 16 minus 5k. So if I add 9k to both sides, that'll give me 4k on the right. I'm going to subtract 16 from both sides, so I get negative 10. And divide, and my k is equal to negative 5 halves. All right. So this one, I have to isolate my exponential before I can do anything else. So I'm going to subtract that 8, so I get negative 5 times 8 to the negative 5y minus 6 power equals negative 48. Then I have to divide by a negative 5. So I get 8 to the negative 5y minus 6 power equals a positive 48 over 5. So now that I have this, I am going to take the log of both sides. So I end up with the natural log of 8 to the negative 5y minus 6 power equals a natural log of 48 over 5. So here this exponent comes out and I get negative 5y minus 6 times the natural log of 8 equals the natural log of 48 over 5. So to get this away from my parentheses here, I'm going to divide. So I get negative 5y minus 6 equals the natural log of 48 over 5 divided by the natural log of 8. Okay, this is different than when we're condensing them. Like, see how this is different than this right here? This is a single log because there was subtraction. This is not a single log because I was literally dividing two logs. Then I'm going to add 6 to both sides, so I get negative 5y equals the natural log of 48 over 5 over the natural log of 8 and plus 6. I want to divide by a negative 5. But since I already have this fraction, I can also multiply by a negative 1/5. So y equals negative 1/5, big old parentheses, natural log of 48 over 5 over the natural log of 8 plus 6, close my big old parentheses. There is my y value. All right, and you can omit, I told you can omit number 71. So this concludes part 3.